do an introduction?
Yeah.
Okay.
Welcome, guys. Welcome to everyone who is watching today. And we have a very special guest today here. It's Emily from IBM. Emily is well known as a Java champion, as an engineer working with MicroProfile. And Emily, thank you very much for being here. Thank you for accepting our invitation.
Thank you, Elder, for inviting me to do this live talk. So I'm Emily Jiang. I'm a Java champion, and also I'm a Liberty architect for MicroProfile and CDI. As the Elder says, I work for IBM. I enjoy my work in IBM, so which is a great company to work for. So in today's talk, I'm going to talk about the new modern smart way to develop microservices for Istio, with emphasis on the programming module called Eclipse MicroProfile. I will talk like briefly about Istio as well. In today's session, I will focus on creating microservices, and with the intention, these microservices will be deployed to the service mesh architecture, for example, Istio. If there's more like interest to see the action in action MicroProfile, and then working inside Istio in the cloud and etc., I can always come back to do another talk. So it's let's first step back to look at in the last couple of decades and how IT evolved. Like more than 10 years ago, like 15 years ago, we all do the waterfall model. Basically, we do the analyze. We get a problem, a requirement, and then we analyze it, we design, and we put it to production. Normally, it took like a month or year to get that product to be released. By the time it's released, the requirement is no longer valid. So we ran into this kind of problem over again, and then luckily we came up with a new, work pattern, which is agile. So we do like a very short release life cycle. We do monthly release. We release fast and then put it to production quickly. And however, this is kind of put a burden to a DevOps pipeline. So DevOps deal with this frequent update, and which require new hardware to go with it. Luckily, cloud came to rescue. Cloud have a bigger kind of pool of hardware for you to, or software for you to choose from. And then with the time goes by, we find out, oh, we have a giant application. Every month we only change a few line code, and we need to carry the bigger chunk to the release cycle, and we need to do a lot of unnecessary testing for the code we have never touched. So which is why we came up with the methodology or another pattern called microservices. So basically, microservices is kind of split the monolith application, which is the old-fashioned giant application, into smaller chunks, which is called the little chunk can do a single kind of operations or functionalities. We call it microservices. So for the big, when the break up the big application to microservices, and very soon we will have hundreds of microservices. We run into a microservices spider web, and then we need some orchestrator to manage this microservice. And with this requirement, and came up with a new infrastructure called service mesh. Service mesh is to manage services. So it's manage a network of services, and it can provide a functionality of observability, resilience, and routing can route one request to a different to a particular service per se, and also can provide a secure for transport layer security. And also you can specify some policy like a blue-green deployment, and also you can split the traffic, and you can define all these policies, and then the service mesh can do the policy enforcement. If you said I want to do like a 10% of traffic route to this particular service, and then it will do what you are asked for. So it's because there's a policy enforcement to honor your request. For the implementation for the service mesh, and there's a couple implementations. One is called Linkd. Some people might have heard of it. The other one is Istio. Istio is pretty popular. Last year, it's 31st July, it was released. Version 1 was released, and it generated a massive uptake. So it's a lot of interest went into Istio. And Istio is a service mesh designed to connect, manage, and secure your microservices. And then it's with a bigger picture, you have all the microservices, all the DevOps pipeline, and etc. And you start to think about the Istio, how the Istio can work into that cloud infrastructure. The first of all, let's take a look at the Istio architecture. So Istio has two major parts. One part is the data plane. The data plane is nothing more except the, as you can see here, the proxies. So in Istio, this is Envoy proxies, the Istio sidecar. So it's directly from Lyft contribute this data plane. So the data plane, basically, the major functionality of data plane is hijack services, invocations, and then add some particular quality of services, and then it's route the request to the backend. For example, here, you are service A calling into service B. In your code, you might directly call into service B. However, there's a proxy direct hijack the request, and then send the request to another proxy, and then go to the backend. And in this, once it goes through the proxy, it can feel free to add some headers and do some particular a transport layer security and etc. and add a lot of quality services. So this is the data plane. Data plane is very powerful. It knows how to route to a particular endpoint. However, it needs a master to tell the data plane, how to get there, what kind of command to what kind of quality service policy it needs to listen to. So which is a control plane. The control plane is a kind of commander, almost like a commander for this data plane. The control plane has three parts. One is the palette, mixer, and citadel. So the palette is responsible for discover service and also supply the config data. And the mixer is more like a policy enforcer. So if you specify any policy, for example, 10% traffic route to one particular service, it is kind of ensure this policy is honored. And the citadel is kind of the authentication, authorization policy, and also the implementation as well. So this is big bird's eye view of the Istio architecture. So from the from the developer point of view, you don't need to worry about any data plane or control plane. All you need to worry about how can you develop your cloud native applications, and then is kind of the DevOps need to come up with the policies and how to define, like, are you going to do the blue-green deployment, or are you going to inject some fault, and etc. So are you going to do the transport layer security? So is also the configuration is just associated with all this policy writing. And in this talk, we are not going to talk about how to write the policies, how to do the routings, and etc. We emphasize how to, for the application developer, microservice developer, how can you ensure you can design the good microservices fit for Istio architecture. So this is kind of come to the best practices of cloud native microservices. So I look back and also from my own experience and etc. I concluded with these 7 best practices. The first one, your microservice need to be a RESTful microservice. Basically, that it shouldn't contain any state in your microservice. So the service should behave like a cat or notepad. So it is one service can be destroyed at any given time, and nothing will get lost. So this is the first thing. So basically, it's in the service mesh, and there's hundreds of microservices. Is maybe thousands of instances of each microservice, the service, and any given microservice died, and nothing get lost. It's RESTful. Another thing is configurable. So your microservice, once in the cloud, you can configure in the cloud. You don't need to repackage your microservice if you have to change some configuration. The third one is once you deploy your microservice in the cloud, you don't want your microservice is flaky. You want your microservice to be resilient, fault tolerant. It can behave at any kind of situation. And the fourth one is, the service mesh is a bigger ocean, and you want your microservice to be able to advertise itself and capable to tell others what is capable, what is functionality. So can be discovered. The fifth one is you have the ability to secure your microservice. Your microservice is alone in the cloud. You need to control what kind of user is able to invoke the microservice. The last one is the monitorable. Once the microservice is deployed to the cloud, and you can still monitor how well is doing, and how many traffic it is serving, and what's the response time, and etc. So you can take a closer control. I mean, what is the kind of, another thing is what kind of invocation hierarchy, which microservice invoke, and how much time did it take for this request to be returned. So these are, monitorable and traceable. Finally, you want to create an intelligent microservice. Basically, your microservice has brain. Your microservice is able to tell the cloud infrastructure how healthy it is. Is it still well enough to be able to serve the request? Is it still alive? So is with this and the cloud infrastructure, if it says, hey, I'm a healthy cloud, and send a request to me, and the cloud, the infrastructure such as Kubernetes can send a request to the microservice. So this is 7 best practices I have summarized for doing good cloud native microservices. And after here, you might think, okay, now I'm writing microservices, and I got a business logic to deal with. And now I have this 7 best practices to worry about as well. And thinking you write hundreds of microservices, It's very soon. If you just like look at this quality service, is that you need to spend weeks to be able to work on any given microservice, any given quality service. So which is not what you are paying for. What you are paying for is to come up to concentrate on your business logic. If you work on the bank, you need to write banking software. It's not like to write a quality service, like how to write a security framework per se. So luckily, you don't need to worry about any of this. The MicroProfile community or programming, the programming model is here to help. So if you don't know MicroProfile was established in 2016. It's just over 2 years, and by company including IBM, Red Hat, Tommy Troy, Piara, LJC, and also Sujava as well. There's a companies and together with the communities, and later on Oracle and Microsoft, NetBank, Cumulus EE, and etc. all joined. So there's a huge community. Is basically community driven, and there's no implement in MicroProfile. So the aim is to optimize Java for microservice architecture, and as I say, is there's a purely community driven and purely open source. We have a lightweight iterative process, and we release specs, APIs, and TCKs, and all the APIs and spec can be TCKs can be found in the Maven Central. There's no reference implementation because we do not want to differentiate any given implementation to be superior. So all the implementations are equal. So up to now, and we have many implementations for you to choose from. In IBM, we have WebSphere Liberty, Open Liberty, Piara has Piara, which is version of, which is kind of service version with Glassfish, and Tommy Tribe has Apache Tommy EE, and Cumulus EE, and Oracle has Halidon, was released, was announced last year. Red Hat has implementation. SmallRye is library implementation for all the MicroProfile stacks, and Quarkus, which is newly released, was announced at the DevOps UK. The DevNexus in January. It was announced that day, and also there was a talk by Justin in the DevNexus. But Quarkus and Songtail is all directly consumer SmallRye. So you can see there's a lot implementations to support MicroProfile. The link there, the wiki, the MicroProfile implementation, and list all the runtime to implement which version of the MicroProfile specifications, etc. So obviously, I work on, as I mentioned earlier, I work on Liberty, and also I work on MicroProfile. Liberty is currently doing a monthly release, and in the 1903, we implement a MicroProfile 2.2 release. So you can go ahead to download a 1903 and to start to experiment MicroProfile 2.2, which is listed here. So here, as you can see, this busy chart here to demonstrate how fast MicroProfile is evolving. As you can see, the first in 2016, we released MicroProfile 1.0, just taken 3, Java EE specifications, JAX-RS, CDI, and JSON-P. And in the February this year, we released MicroProfile 2.2, and including for tolerance, Open API, and Open Tracing, and REST client. For me, and in the first release, MicroProfile it has the first MicroProfile spec, which is config, which is the MicroProfile spec I initiated. So I initiate the MicroProfile config and also MicroProfile for tolerance, and also the MicroProfile service mesh as well. So I involved in quite a few other MicroProfile specifications. So I'm really passionate about MicroProfile. So I have strong belief MicroProfile is the great programming model for doing cloud native microservices. Hopefully, in the next few slides, I will go through them and give you a quick demo of MicroProfile specifications to demonstrate how easily, you can create micro services using this programming model. So as I mentioned earlier, when you create cloud native applications, first you need to create a RESTful services. So how can I create a RESTful services? So you use these 5 building blocks to achieve that. So I will go through each of them in the next few slides. So the first one is JAX-RS. You want to do a REST call. So for doing a JAX-RS, you first is like in the left-hand side, do an application path. So just directly extend the application, and then you can define your endpoint. In here, you can define what is response type. Like in here, you can say JSON object. With the JAX-RS, and then you think, okay, I create a microservice, JAX-RS service, and then your microservice is not standalone. You need to invoke another microservice, and you need to communicate with others. So how can you communicate with others? Obviously, you need a REST client. So in JAX-RS REST client, if you know JAX-RS REST client is not type safe client, and if you only can find a problem during runtime, and which is not something is not something acceptable, or not something is good enough. So that's why in MicroProfile we have come up with MicroProfile REST client, which is to create a type safe JAX-RS client. How it works? So basically, if you try to invoke a service B, and then you can directly create a service B interface. Basically, is you can query what service B's interface is like. You directly create an interface or service B, and to say, okay, service B has get properties endpoint. You can directly the get operation, and then you can register as a REST client, and then in your own service A, you can directly inject that REST client to your class, to your JAX-RS endpoint. And then you are asking, okay, I just have a service B interface, and I inject to it, and eventually I still need to wire them up. So service A call into service B. How can I make this connection? So this connection all come with this, so that MP REST start URL is directly point to the endpoint. So if the service B is under HP localhost 9080/systems, so you directly just configure this one, and then in your service A application or microservice, and you can directly use this inject instance of service B, and then you can directly call the client any method of it, and then the JAX-RS call will directly route to the backend of service B. So that's kind of up to now. You can create one microservice. You can, and then you think, okay, I need to call another microservice, and then you have 2 microservices, A call B. And even with your microservice inside itself, you need to make sure you can create a loosely coupled microservice. even inside the microservice A or inside the microservice B, you need to think about how can I create a properly structured microservice. The way to achieve this is by using context dependency injection, which is called CDI. If you know Spring is like a Spring injection, so you from once you use the CDI, you will stop use new instance. You stop calling the constructor yourself. You just need to add inject. If you need an instance, you just add inject. I need the instance system client. You just do like that. Is add inject is kind of similar to the Spring injection add wired. And then is now is like you're thinking, okay, I have loosely coupled microservice, and also I use JAX as the REST client and to be able to call my microservice. What about on the wire payload? So on the wire payload, luckily in the Java EE we have two specifications, JSON-B and JSON-P. And in the Java EE 8 we have JSON-B, which is a great specification. With the introduction of JSON-B and your JAX as the endpoint and also the method implementation, and is much simpler. So on the wire, if you want to pass any particular object, you just need to say, okay, for example, in this example here, my get operation, on the wire will be a JSON payload. That's the inventory list. You only need to create a module to say inventory list, and JSON-B will do all the complicated stuff for you to do the serialization or deserialization for you. So your code is stay clean. So up to now, you kind of have some basic idea about a couple of microservices, how can they invoke each other, and also is how can I create microservices. So now is I would like to demonstrate a little bit so that you understand what I'm talking about. So in here, so here I have a service A and a service B. So a service B is very simple. I just let's say I just print a hello and etc. So it's just JAX as JAX as service. So you can see I have an application. Make it bigger. So I directly have an extend application, and then it has a path there. Then I create my my JAX resources. In these resources, this is the major kind of important stuff. So I have a hello operation. So in hello operation, basically this is I want to do a hello from service B and then print out the date and a host name and etc. And then I configured some fault. So basically sometimes it works, sometimes not working. So to demonstrate some flaky service. So this is as you can see is very very simple. Just I have a couple class and then it can give me a response. Let me show you. So this is my service. So it's listen. I already have this microservice up and running on OpenLiberty. So it's on the port 9081. Demo you can see here. You can see here is in the application. I have this demo, and then is in the JAX as REST client, JAX as resources. I have a /b. So the endpoint will be demo/b. So you can see here, and sometimes it works, sometimes it doesn't work. So yeah, so that's on purpose. So you can see that you can get all the payload without any problem. And in my example here, I have service A call into service B. How can I achieve this connection? I know my service B is is at localhost 1981 demo B. So my service A, I want to use the MicroProfile REST client. So basically, I register a REST client. I know the backend is this. I can directly do this. And then as I say, because the service B is a hello and it is a get operation, so I can do something like that. That is a kind of interface of service B. So the callee. And in the service A endpoint, I can directly look at inject REST client and inject the service B here. Here is I didn't do anything particular. I just like directly call a service B here. So if my service is running OpenLiberty, so you can see here, if I do the service A, see, hello is directly calling to my service A. So I can give you a live demo here. You can see I actually I'm using here, using this service, no fake service. So I save it, and OpenLiberty automatically restart the application. Now you can see hello to Java, right? So this is up to now, you know, is service A directly call into service B. Let's go back to the, so we have achieved a RESTful service. Let's go back to the slides again. So with if you have a couple service, you can manage your service without any problem. And you have a table. You see, okay, which service is doing what, is okay. You can manage it. But once you have hundreds of microservices, you need to make sure, okay, how can I differentiate them, and which service is doing what, and how can I secure them? How can I create a resilient microservice? How can I configure them? So this is basically the come to this 4 building block: OpenAPI, GWT, for tolerance, and config. So for the OpenAPI, so basically it's MicroProfile OpenAPI is based on Swagger API. If you know Swagger API, is MicroProfile API is kind of very similar, and you won't have any difficulty to understand it. And in the MicroProfile OpenAPI, it can read in some metadata, or can honor the JAX-S annotations and directly create an OpenAPI for you. In OpenLiberty, we also add some value add. You can have a UI version, like here, you can have a UI version, and can allow you directly invoke the operations as well. So is an auto box, is automatically give you the description, also the Open API. However, you can provide further information. You can use the Open API annotations like at operation. You can provide a summary or description, and also the API response, request, parameter, etc. You're free to add any more information as you wish. So this is on the right-hand side is payload when you do /open API. With that, let me quickly look my code here. So in my example here, I didn't do anything. I haven't got any annotations. However, and there's the Open API endpoint already being exposed for you. if you my first service A is on the 9080, so now I can do Open API. You can see, so my Open API, you can see all the path is demo A, and the operation is get operation is called service B, and I didn't provide anything. It's just a default response and etc. And also the type of the return is a string. And if you want to provide better, description, you can directly, for example, here, save time, I directly pre-coded a bit. So I can just say operation summary for this call service B, and then description calling service B. Now I can go back here, I refresh. Okay, save it. Okay, API. Okay. Okay, I need to is normally is going to work okay. For example, here the Open API seems is not displayed or okay. I will follow up with afterwards, and to figure out why it's not working. So here I saved it. I saved the service A. Okay. First time is done. Open API. Okay, let's move on to the next one. Let's see. Okay, so it's debug that later. So it's the other thing is MicroProfile GWT. So the MicroProfile GWT is to propagate the GWT token along the downstream. For example, you have a service A calling into service B, and then call into service C. If it's a service B got all the security token and etc. And when the call into the backend service C, it should directly pass down all the credentials and etc. Which is the MicroProfile GWT is able to help. So basically, it's all this the GWT the token is automatically propagated to the downstream. How the GWT works is directly work together with the Java EE security. So in the rules allowed in this code snippet, rules allowed, you have admin and user. So in this JAX-S backend resources, you say, okay, so this operation, I only want admin or user be able to access it. So the MicroProfile GWT send the token away, the token in, that's including the calling user, the calling user, the access group, and etc. And then the runtime is able to figure out whether this caller is is allowed or not, is in the right rules allowed category. So it can either reject or accept this request. So this is GWT. So the third one is MicroProfile for Tolerance. So the MicroProfile for Tolerance is to provide a way to create a bulletproof microservices. So basically, it has a few like capabilities, like a retry, bulkhead, and circuit breaker, and timeout. And if it's all these kind of retries doesn't work, and you have the final method of final capability, which is a fallback. So you can fall back to a different operation. So this is MicroProfile for tolerance. And the next one is MicroProfile config. So MicroProfile config is provide a way to configure your microservices everywhere, anywhere you are. So the MicroProfile config is also provide the way for you to externalize your configuration from your microservices, and which is one of the bigger the first factor in the 12-factor app when you're trying to create in the which is a well-known methodology to create best practice microservices. So in the MicroProfile config, and it has config sources, and also it creates some APIs to be able to inject this, or to be able to look after these configures from the external configure sources, or inject configure properties to your applications. So for the configure sources, and it have some default configure sources. For example, the system properties, environment variables, and also the prepackaged MicroProfile config or properties is inside your application. So it's on the class path and the meta info folder. And you can also provide customer configure sources. All of these configure sources have priority. We call it config ordinal. Each configure property can exist in any given configure source, or they can be duplicated. In this example here, you can see I/O Open Liberty Guide, inventory, in maintenance exists in the MicroProfile configure properties, and also you can create a customer configure property configure sources, and then you give it a priority 150. So, and then in your code, you can just directly inject the I/O Open Liberty Guides inventory in maintenance into your code. So basically, it's in maintenance will be the value will be injected into the in maintenance. In this example here, because this has a higher ordinal, so the true will be injected into the application. So this is config. Let me try to see. Okay. So as we know, and sometimes it's not working on my microservice. Sometimes it works, right? And now because according to my best practices rule, I need to create a bulletproof microservices. I want this working all the time, and it's my responsibility. I'm the author of the service A. Even though I'm calling service B, but I'm not the author of service B. Maybe service B is somewhere by another company or by another team. They probably cannot fix it in a timely manner. Is my responsibility. I need to return a good. I need to return a response to my client all the time. So how can I return a good response to my client? So here, I know for example, I use MicroProfile for tolerance. I can directly to say, okay, I want to have a retry. I save it. Now I can go back here. See, you can, it always works. So 30, you can see the core count 39, and then is you didn't get 40, is you got 41 straight away. That's because 40 failed, and then it's like send another request without knowing it, and then call the backend again. So you will get the 41. So you get a successful response back. For example, this is kind of you can using retry to get it working. For example, like sometimes it's hard failure. You cannot get a retry. As I mentioned earlier, the fallback is your last resort. So, and the MicroProfile also has the fallback capability. So you can do a fallback method, for example, my fallback. So now it's a kind of, you need to create exactly same signature for the fallback operation. So you do like that. You can directly, you can return hello and the fallback. I save it. So now if I go back here, so here is automatically, if it doesn't work, is you directly call into fallback. So this is very useful. So this fallback is very important. For example, even your microservice deployed to the service mesh in Istio, and sometimes you get hard failure. You always should prepare to use fallback, and to have this is kind of the best, safest resolution for all kinds of failures. Whatever the backend or whatever the infrastructure can guarantee, it cannot guarantee 100%. You should always make sure you have the last resort fallback. So this is quickly demonstrate the fault tolerance and fault tolerance, fallback, and retry. The next one, as I mentioned earlier, about the configuration. So, and here I mentioned earlier, like you can use this is a MicroProfile config. At inject is CDI. The config properties is directly from the MicroProfile config specification. You can configure the property. You can inject the configure property such as a username and to your application. Where does this username is defined? In my demonstration here is defined in the MicroProfile configure properties. So here, for example, I define elder for as a username, and in my client, in my client here, I can say hello. Instead of doing that, you can say hello, elder, username. Then I add some space. So now you can see hello elder, so I can directly inject that. So this is not very exciting. So okay, this is the configuration from the inside of my application, but you said okay, the configuration should be external. So once I change the config, I don't need to change my application. So you can write your own customer config source to anywhere, and then just let your application to load that. In Open Liberty, we automatically opt in the server XML as a configure source. So if here I directly to say my username is for in the so Java. So I save it. So this is server XML is configure source. this config source ordinal is 500. The config underscore ordinal 500, which is higher than the MicroProfile config.properties. So I expect the username, when I save it, the username should be SoJava instead of Elder. Yeah, you can see hello SoJava instead of Elder. So it's directly like, so I didn't change my application at all. So I can configure it anywhere. So if you deploy your microservice in the cloud, as you know, is Kubernetes is a kind of very well-known infrastructure, and you can use a config map to configure it. So I have one slide to talk about in the next few minutes. Let's go back to the here again. Okay, so up to now, you know, you create a Red Hat microservice, you try your best to secure your microservice and configure your microservice and create a bulletproof microservice. And now you're just wondering how well is my microservice performing. So you want operation focus. So MicroProfile provide 3 building blocks: health check, metrics, open tracing, so to allow you to monitor your microservice. So for the health check, so basically this is make your microservice intelligent. It's able to tell the underlying infrastructure, such as Kubernetes, how healthy is the microservice. So you can directly implement the health check, which is from MicroProfile, and to say under what kind of circumstances are not healthy, under what kind of circumstances is healthy. And then is in the payload here, and you can see it can directly have the endpoint /health, and it can display the name and display all the data and etc. Let's go back to the code here. If I do a so you can see this is I have a lifetime 365, and then have a service A and then says up. That's because in my code I have a service A health, so I can directly like implement the health check. Yeah, I have service A is the name, and then this is the data. Obviously, this is no op. So you can specify and what kind of circumstances, if for in the run out of memory, etc., it will be down. Otherwise, it will be up. So this is health check. The next one is the metrics. So it's in order to monitor how well your microservice is doing. Your microservice and need to emit some data. So one is kind of obviously important data is how much response time did you take to process this request, or how many times have you been invoked. So all these kind of the metrics can be achieved by MicroProfile metrics. So in the let me go back to the demo here again, so I can see the actually it's directly have these metrics. Auto box, I didn't do anything, and it give you class loading and also the thread counter and etc. It has a lot of stuff, and also because I have fault tolerance, it also tell me the fault tolerance invocation, the timeout, and also the fault tolerance. For example, how many times been failed, how many times the fallback has been invoked per se. So this is MicroProfile metrics. The other thing, if you want to add any more metrics, for example, you can add the like some other like meter to see what is the response time and etc. You can do like that directly to next one. Okay, save it, and then you can invoke the service. You can collect some data. So, matrix. So this is a matrix that has everything, and you can to see the application, like do the slash application. So that's only give you the application levels and metrics. So it's this is kind of the metrics. You know, it's very important to have this metrics data, is because you can once your microservice is in the cloud, you can use the for in the service mesh like Istio has Jaeger for Istio Prometheus or a Grafana to view all this draw your graph and etc. to view all this service invocation and etc. So up to now we have the metrics, and also we have the health check. So the next one is open tracing. So this is a particular, important, it's very important, because in the service mesh architecture, like this spider web, you need to wait to trace this service invocation, so chain them up, like a service A call service B call service C call D, and etc. You need a way to link them all up. So that if you get a slow response, you need to find out where's the bottleneck. Luckily, MicroProfile open tracing and can do this all for you. It provides the capability to propagate a tracing header. So it can correlate all these trace span. It have one parent trace span, and then all the children trace span. So basically, it's join up one tracer, so it's all linked. So you can look at each span to find out where the bottleneck. So AutoBox, all the JAX-S invocation are traced. You don't need to add anything. It is all the trace header being propagated. For some other like method invocation, and you can add some APIs for the add trace and etc. to trace to add any particular trace. And if you want to skip trace, you can have use annotation to skip trace, no trace. So this is a kind of observe, so that observability and to see how well your microservice is doing in the cloud. So up to now, I have gone through all the specifications, and also it's kind of demonstrate briefly how it works. You will ask, where can I get started? So how can I create my own application? Luckily, recently we have started on MicroProfile.io. So it's to get you started. So let me give you a quick demo of that. So this is a website start. This is kind of the starter. So allow you to create a microservices. You can choose any given MicroProfile version. At the moment is 2.2 is the latest, and actually we have PR to be merged to get 2.2 to be added to the list. At the moment, I demonstrated for in the 2.1. So in the MicroProfile 2.1, there's 4 implementations, and I choose for in the Open Liberty. And I want examples of all the specifications. So I create a download, and then I can download that. So here I get this demo. So it's So this is my Maven project. So in my command window here, I can go to the demo. Here I did a demo to. So I have a Maven project. I can directly do a Maven clean install. It can build my application. When it's finished, it gives me a jar, so I can start my microservice with this. So I can do a Java managed jar and go to the target. So you can see here I have a demoed jar, so I can do Java managed jar and demoed jar. It directly go to the go to a local host 8181. You can see this is the starter. So this is on Open Liberty. This is JAX-RS. This is a demonstrate JAX-RS, and then you can demonstrate inject. So if you want to get to the to see how the code is like, so you can open the code. So here is the demo 2. I can open it. So this is all this code snippet here. So it's a great way for you to learn, I mean, how the things work. So you can see add inject. And if you want to learn the health check, so you can do the health check. And also the metrics. You can see the how to use the different metrics and etc. As you can see, it's a JAX-RS application path, and then JAX-RS REST resources. And here is the Liberty configuration, and also you have a poll to directly use some Liberty plugins and etc. So if you want to use a different runtime, you just feel free to choose a different one. The other thing is that if you really want to learn something, each individual specs, so we have OpenLiberty.io have guides. So you can look at all the kind of, for that MicroProfile guides and etc. If I say view all OpenLiberty guide, you can search MicroProfile. Each guide is only takes about half an hour. Also, or 15 to half an hour. So it's a step by step, give you some explanation. This one is about CDI. So for you to play with it. So this is Open Liberty is completely free. If you are happy with the guide, please like it. Add your star to style. So this is about how to get started. So I will use the next few minutes, a few minutes to talk briefly about the cloud infrastructure and Istio. So now is you have creating a microservice and try your best to create to add all the quality service to your microservice, and also make sure your microservice is resilient, configurable, and etc. And next thing, do you deploy to the cloud? So at the moment, and the first thing when you deploy to the cloud, you need to containerize it. You need Docker, and after Docker, you have this container you deploy to the Kubernetes. Kubernetes and can do the can manage microservice. However, it cannot do the a proper traffic routing based on some 10% go to a service, go to a different service, and etc. So which is why you need Istio. So basically, this is all natural fit. you first think about how to containerize it, and then you deploy to Kubernetes, and then you install Istio to properly manage your service mesh. So as I say, the title is about I create a microservice is suitable for Istio, and obviously Istio is sit on top of the Kubernetes. Also, Istio can sit on some other infrastructure. However, now is majority people use case is use Kubernetes. So I want to use Kubernetes as an example to to demonstrate why MicroProfile is best for the cloud. So it's in the MicroProfile config. So I have the configure source. I have the APIs can directly inject the configure properties to the MicroProfile applications. So the configure sources can be anywhere. I mentioned briefly in Kubernetes, you can create a configure map. So in here, here is the create a configure map. So you can create a configure map, message equals greeting. And then is in the Kubernetes, YAML file, you can say, okay, please map this one into environment variable. You can say, okay, the name is greeting, and the value, the key is a message, for example, here. And then you can directly get the value on the message to this greeting environment variable. In your code, you can directly say, okay, you inject a greeting, and the value you get will be here, greetings. And as I mentioned earlier, and you can create a configure map. Maybe you define greeting in some other places, depending on which one is a higher priority. Because this one configure map directly mapped into the environment variable, which is have the priority of the 300 is a pretty high priority. The other thing is the health check. Health check is a intelligent way to tell underlying infrastructure how well your microservice is doing. If your microservice is deployed to Istio, it has Kubernetes. Kubernetes has readiness and liveness probe, so it can directly poke one like HTTP GET, HTTP operation in this example snippet here, can directly call into like localhost 9080/health, poke that endpoint to see what's a response. If its response says up, and the Kubernetes saying, okay, it's good, it's ready, I can route a request. If it's down, and Kubernetes says, no, I'm not going to route a request to this this port because it's not healthy. So here is in this snippet is an initial delay. So the first time when your microservice first start up, it will wait 15 seconds. And period second is every 5 seconds Kubernetes will poke this endpoint to see, are you still okay? Are you still okay? Etc. The failure threshold is if you failed once, and Kubernetes say, okay, you're not. I'm not going to route a request to you because you're not well. So this is MicroProfile health check. So it's how work with Kubernetes, which is kind of used by Istio as well. So Istio normally sits on top of Kubernetes. So one the very relevant spec is the MicroProfile open tracing I mentioned earlier, and it's fitting beautifully with Istio, because Istio has Yaga, so to be able to view all the trace correlation and all the trace data, and then be able to draw the graph. However, Istio guide especially and call out 7 HTTP headers need to be propagated by application. And luckily, MicroProfile open tracing automatically does it for you. So application developers can just concentrate on the business logic. Don't need to do any like trace header propagation and etc. It can propagate this header without doing anything, because MicroProfile Open Tracing does everything for you. And you even don't need to add annotations if you are doing a JAX request. So here's a final picture. So you use MicroProfile and develop your application, and then you can rest assured your microservice is going to work well in the service mesh architecture. So your microservice is able to communicate well with the infrastructure, and can be viewed and can be traceable as well. So with that, let's kind of come to the end of this talk. This is a few useful links. I recommend you click to these links to find out any further information. The MicroProfile.io, you can get involved and look at each individual specs. Open Liberty guides and then teach you how to use MicroProfile specs on Open Liberty, but also you can learn it use in some other runtime. And then Docker, Kubernetes, and Istio. And also, I mentioned briefly, also I initiate MicroProfile Service Mesh, basically trying to come up with best practices, how to write microservices, utilize the service mesh architecture. So basically, this is my bigger focus. I want to position MicroProfile as the best programming model for service mesh, and Istio I want to write up my experiences and the best practices for doing microservices in the service mesh. And also last year I published blog under Eclipse newsletter is about look at MicroProfile and together with Istio. So if you want to learn anything about MicroProfile and also the Istio, I have a code snippet teach you how to use each individual specifications in the Istio, and with some quite a lot demonstration as well. So if you are like interested in Istio usage and etc., I strongly recommend you to get involved in this MicroProfile spec. So with that, that's all I have for you today. Are there any questions?
Yes, there are a question from Carlos. He's asking if you will put these slides or your reference in some place where he can get and follow with you after.
Yeah, I can share that on slide share, and then I can tweet about it.
Oh, great. So I can put the URL on the description of the video so people can...
Yeah, I will send to you as well.
Awesome. Yeah. Awesome. Great. Let me check if there's another question. No more questions. You have something else to say, Emily?
Yeah, this is again.
Just maybe should stop your screen share so people can see.
Oh yeah. Let me stop my screen share. Stop.
Yeah.
Go to the Google Chrome. Stop. Stop.
Yeah, there you go.
Oh, you can see me. Cool. Yeah. So again, thank you so much for having me, and I hope you find it useful, and hope to see many of you in some conferences face to face. If you have any question and etc., I'll be on Twitter. So Emily FH Jiang, JIANG, and follow me on Twitter. So. And also I'm on LinkedIn as well. So would love to hear any feedback from any of you.
Great. So thank you, Emily, again. Hope you enjoy the rest of your day. And guys, all of you who watched this today, Keep your alerts to the next webinars from Java at Cloud Age, and see you next time. Bye-bye.
Yeah, bye. Thank you. Bye. Bye.